Hello everyone, and let's continue our tests for right triangle trigonometry. Now you may be wondering, I post a lot of test videos for right triangle trigonometry, and this is the fifth one. Now, let me tell you, this will end until the sixth part of it, because you see, what do you call this one? In the previous questions, right? I've given you questions like about, yeah, right triangles, so on and so forth, yeah. But in terms of solving problems, it's not actually complete. We only know how to solve problems like what if we have a given angle, but it's a special angle, and it is inputted in a given trigonometric function. And then we learn also about finding the sixth trigonometric ratio. But how about when it comes to this problem, like finding the legs or find the missing side of a right triangle? So that would be the main focus on the test 5, finding the at least one of the legs of the right triangle, and uh maybe we're going also to find the missing angle in a right triangle. That angle that I'm referring to is an acute angle. All right, so let's not proceed. All right, so let's go to our first problem. Let's find the legs of a given right triangle, or sorry, given right triangles where their hypotenuse and acute angle are given. It's not is, by the way, it's are given. Forgive me. All right, so let's start first with the left. So let's recall the video that I made about finding the legs of a given right triangle. So if you have a given hypotenuse and a given acute angle, and it's located on the bottom of the right triangle, what happens here is that we can find the sides of it. The horizontal side, which is this one, and then the vertical side. We can actually. So by how? So let be x as the horizontal side and y as the vertical side, or the height of the right triangle. So in this case, if you're going to find the horizontal side of the right triangle, all we need to do is we multiply the hypotenuse and cosine theta together. That's it, all right? As for the y, right? For the y, instead of I mean it's almost the same as the x, right? But the only difference that we're going to multiply hypotenuse with sine theta instead of cosine. All right. So for horizontal, x cosine. All right. For vertical, y sine. That's it. Okay. So let's start first with your x. So your hypotenuse is 3.57 millimeters times cosine of 25 degrees. So here we can get the value here uh, by two decimal places. So 3.57 times cosine of 25 degrees. Here we will have 3.24 millimeters. All right. So that's for your um yeah, that's for the base of the right triangle, or the horizontal side of the right triangle. Now for the vertical one, so the same thing for the hypotenuse, 3.57 millimeters times sine of 25 degrees. All right, so by two decimal places, this would be 1.51 millimeters, right? 1.51 millimeters. And yay, that's it. That's the answer. All right, so your x here, or the horizontal side, is 3.24. And for your vertical side, it's 1.51 millimeters. Okay, so yeah, that's it for our right triangle to the left. Now, how about to the right? Okay, so here's the thing, right? Let x be the horizontal side and y be the vertical side. All right. So here, of course, our x would be the base, or the horizontal, and the y would be the height. Now, the only difference between on the left of the triangle and the right is that the acute angle is actually on the top instead of the bottom. We have a given acute angle of 19 degrees. So how can we find the horizontal side and the vertical side? So how can we do that? So there are two ways. Let's start first with the first way. Okay. The first way is that since we have an acute angle on the top instead on the bottom, what happens is that the usage of trigonometric functions are reversed. All right. What do I mean by that? What do I mean by reversed? Earlier, right, we have an angle at the bottom. So if we have an angle on the bottom, all right, and then we find our x and y. So here we will have h times cosine theta. Then for the y, h times sine theta. Here, however, we're going to reverse it. All right. Actually, I don't know if reverse. No, maybe exchange rather. Right. So here, your x, this would be instead of cosine, we will have sine. Right. And for the y, right, instead of sine, we will have cosine. Right? We will have cosine. I think I already explained this in one of my previous videos about it. But yeah, all right? If we have an angle on the top instead of the bottom, what happens? The y will have cosine and x will have sine instead. So let's solve the problem. So let's start first with our x. So our x is hypotenuse. So we have 67.25 miles times sine of 19 degrees. So in two decimal places, 67.25 times sine of 19 degrees will give you approximately 21.81, no, 89 miles. 21.89 miles. So that's for your x. Now for the y, so we will have the hypotenuse, which is 67.25 miles times cosine of 19 degrees. So here, by two decimal places, we will have 63.59 miles. So 63.59 miles. So these are your answers for your horizontal and for your vertical. All right. There's another way. Like, there's another way to solve this one instead of just interchanging the signs. All right. So the thing is, uh, let me just erase the writing first for a moment. All right. So yeah, going back, there's another way. Now, what is the other way around? Now, the thing is, for horizontal sides, or to be particular, the base of the right triangle, commonly they are used with cosine, while on the vertical side, or the height of the right triangle, they are commonly used with sine theta. All right? So, my point is that is there another way where we can have cosine for x instead of just sine, and y as sine theta. I mean, y used with sine theta instead of just cosine because the acute angle is on the top? Well, to answer that question, yes, there is another way. Like instead of just interchanging them, the usage of the trigonometric function, there's actually another way. Okay? So here, what happens is that yes, we have hypotenuse times cosine, but since the angle is on the top, so we will have 90 degrees minus 19 degrees. Okay, I think I do believe that's equivalent identity. I actually forgot that. But basically, if you want to find the horizontal base of the right triangle, but the given angle is on the top, and you want to use cosine instead of sine, use this formula. All right. Likewise, for the sine, so yes, we will have hypotenuse times sine of 90 degrees minus 19 degrees. You will only do this if and only if the angle is on the top of the right triangle, right? So now the answer here would still be the same, all right? I just substitute, okay? So your hypotenuse is once again 67.25 miles times cosine of let's subtract um 90 by 19, so we will have 71 degrees, all right? So that would mean that for the y we will also have 71 degrees, all right? That's it. All right. So here, let's take a look if they are the same. So here we will have 67.25 times cosine of 71. Yes, it's just the same as the previous one, so we will have approximately 21.89 miles. And for the y, we will have 63.59 miles. So basically, they are just the same. That's it. They are just the same. All right. So this solves our problem, our first problem. Now let's proceed to the next problem. All right. So here we will find a given acute angle in a given right triangle. Let's take a look. I think we have one, two, three. So I think we have three for this second problem. So this one is pretty easy. All right, if you remember our lesson about inverse trigonometric functions, because for us to find the given acute angle in a given right triangle, we're going to use inverse trigonometry functions, all right? So let's start first with the first triangle. So we have 36 and 35. And what would be the angle here? So the first thing that you're going to do is you have to think at least one trigonometric ratio. Okay, at least one trigonometric ratio where we have these given sides. All right, and of course, based from the given acute angle. So let's start first by knowing the sides of the right triangle. Okay, like what do they have? So of course, this is the hypotenuse. All right. Then next we have 35. So this 35, since it is beside with the angle, so this is adjacent. And here, this is the opposite. Now, for us to find the angle, we must find at least one trigonometric ratio that has adjacent and hypotenuse. So let's start with the first one, which is cosine. All right. Remember that cosine theta is equal to adjacent all over hypotenuse. So we can use this trigonometric ratio to find the missing angle. All right. So let's substitute. So our adjacent is 35 and our hypotenuse is 36. Now, what we're going to do is we're going to put inverse trigonometric function on both sides. All right. Or basically, if since we are looking for the angle here, and again, since if we are looking for the angle, we're going to use inverse trigonometric function, right? So what happens is that imagine that you put the cosine to the right. What's left is you have theta is equal to cosine, and then you have an imaginary, no, not imaginary. Imagine that you have like a negative one above the word cos, and then uh, open parenthesis 35 all over 36, then close parenthesis. Okay, just basically you put the the trigonometric function to the right, then put a negative one above, and then open and close parentheses. That's a technique, basically. But remember, this is not negative one. Okay? It looks like one, but it is not negative one. Because this is a symbol of inverse function. It's just like this. If you remember your lessons in uh what goes one if you're a Filipino student, if you remember lessons in general math, this is a common function, okay? Or whatever, it's just a function. But if you're going to find the inverse function, this is what an inverse function would look like. It looks like it has a negative 1, but in reality, that's not a negative 1. It's what you call the inverse of f or inverse function. Similarly, in this case, we have cosine, all right, theta. But if we are going to find its inverse, we will have inverse cosine, all right? So we have this as a result, okay? There's like a negative 1, but it doesn't look like one, all right? So yes, that's what we're going to do. Just basically bring the word cos in front and then close open and close parentheses and then just put an imaginary not imaginary, sorry. Just put like a negative one. But again, this is not negative one, okay? It looks like one, but it doesn't. All right? Or just simply instead of just having, like a negative one or something, even if it is not negative one, just put arc cosine of 35 all over 36. That's it. All right? It's up to you. I think I already uh discussed this one. What it was? I think I already discussed this one previously. Like finding the angle with the use of inverse trigonometric functions. So either of the two, all right? I just give you a recall information. All right? So, yes. Anyway, so let's go back. So for me, I'm just gonna use the first one, right? This because it looks more convenient. Okay, so here all we need to do is use calculator. So our arc cosine or inverse cosine of 35 all over 36. This is approximately at two decimal places 13.54 degrees. Okay, 13. Wait, sorry. Yeah. So this is once again 13.54 degrees. All right? So yes, that's the answer. Now, if you're asking me, is there like another trigonometric ratio we can use for us to find the given acute angle here? Well, to answer that question, yes, there is another trigonometric ratio, which is secant theta. Remember that secant theta is reciprocal to cosine theta. Or in other words, secant theta is hypotenuse all over adjacent, right? So now you can find the angle here. But before that, let's substitute. Remember that your hypotenuse is 36, adjacent is 35. Then remember, if you're going to find the angle, we're going to use inverse trigonometric function. So in this case, what we're going to do is put the word secant to the right. So we will have theta is equal to secant, and then just put it's like a negative one here, but again, this is not a negative one. It looks like one, but it is not a negative one. Then open parentheses, 36 all over 35, then close parentheses. So this is arcsecond of 36 all over 35. Now, the thing is, if you're going to get a calculator, usually the only given trigonometric functions are the three basics, which are the sine, cosine, and tangent. These are the three basic trigonometric ratios that every student should learn in a subject trigonometry. So yeah, yeah. But the thing is, my point is that usually scientific calculators, they don't have reciprocal trigonometric functions. Like sine, cosine, tangent is only given. So that means secant, cosecant, and cotangent are not given. Okay, they're not given in calculator. All right, so how would you find the angle here? All right. So if you have a scientific calculator or you go to the internet, get a calculator, and then you can get the value of inverse secant of 36 all over 35, that's good. Okay. But in case that you want to know like what would be the value of this if we have a given what do you call this one? if we have a given inverse trigonometric function, but it's a given reciprocal trigonometric function. So here it is. So for arcsecant theta, okay, let's just say, remember that uh, we have arcsecant of, what's that again? Wait, arcsecant of hypotenuse all over adjacent, right? So this is just the same as arc cosine of 1 all over hypotenuse all over adjacent. Okay? So in case if you use a reciprocal trigonometric function which is second, okay, but then um you couldn't get the value because it's not present in your calculator, and let's just say it's not also present in the internet, so this is the equivalent of it. So that means we can simply rewrite arcsecant of 36 all over 35 as arc cosine of 1 all over 36 all over 35. Okay, we can simply rewrite it that way. And we can now find the answer here. So arc cosine of 1 all over 36 all over 35, it's also 13.54 degrees. Okay, so that is how you get the answer for this problem. All right, so yes, okay, we are good to go in answering this problem. But let's stop right here. Right, let's continue the rest next time. All right, so once again, the answer here, I actually erased it. This is approximately 13.54 degrees. All right, so let's continue this one next time and see you soon.